Hey guys, today what we're going to be doing is looking at three-dimensional figures and their cross sections. So I'm going to read over the definitions, and then specifically what I'm going to do is show you what it means. So for the very first one, whenever I talk about faces, all I'm talking about are your flat surfaces. When I'm talking about the edges, I'm talking about the segments that make up your shape. When I'm talking about the vertex, I'm talking about your corners. Now, nets is what I need to speak with you specifically about. All right, here are all of my shapes here. Whenever you look at shapes, now this is a cube because its bases are all squares. Whenever you're talking about a face will be your top, sides, and the bottom of it. Your edges will be all of your corners of your, or the segments of your shape. And then your vertices will be where they come to a point, okay? Now, specifically when talking about nets, all that means is when you open up the figure and what you see. So as you can see for this cube, I have my top, I have my bottom, and I have all four sides of it, okay? So whenever you're doing these, all you need to do is make sure that you are thinking about when you open up a shape, okay? The specific shapes that I have listed there are going to be your triangular, here it is, triangular prism, which as you can see, both of your bases are going to be parallel to each other and they're both triangles. When you open it up, my bases, remember, are triangles, but on the inside, they are squares, okay? That's what makes up my triangular prism. Now, when I look at a sphere, not a sphere, but a cylinder, as you guys can see, I have a circular base and another circular base because that's what prism means, is that you have two bases. But when I open up a cylinder, remember again, my bases are going to be circles, but on the inside, it's a rectangle. So anytime you're looking at these, you need to remember what it is made up of. Now, when I talk about pyramids, pyramids only have one base. So if you have a triangular pyramid, your base is going to be a triangle. But unlike when we had a prism, my faces will also be triangles as well. So my base is a triangle, but my faces are all triangles. Unlike when we were looking at the prism, if you remember, I only had two triangle bases and the rest were rectangles. So this is the difference in between a pyramid versus a prism. A pyramid is going to have one base. A prism will have two bases. All right, the next shape that I want to talk about will be your cone. For a cone, again, you guys know that you only have one base. That base is going to be circular. Now, when I open it up, you will see that it looks like a semicircle, kinda. So whenever I'm talking about a cone, remember you are only gonna have one base and then what looks to be kind of like a semicircle. It's just shy of being a semicircle. Now, one thing I need to make sure that you guys all remember is that when you are talking about a prism or a cylinder will always have two bases. Whenever I am talking about a pyramid or a cone, it will always only have one base. So now, the other thing that they speak about in your notes are cross sections. So what it means is if I cut a shape at a particular angle, if you cut a shape such that you cut it so that it is parallel with the base, then it will be whatever your base will be. If you cut it at the angle in which it cuts the face, then it will be whatever shape the face will be. So let's look at some examples. For the first example here, this shape, you guys should know, is a cone. A cone only has one base, and then, of course, it doesn't have any edges because it is a cone. So in this particular case, when it asks you to classify the figure and name the vertices and edges and the bases, for this one, this is classified as a cone because it only has one base. My vertice or vertex would be A because that's where it comes to a point. It has no edges, and my base would be B, which is a circle. For number 2, this is going to be a cylinder. A cylinder, remember again, it has two bases. So my bases in this particular case would be P and Q. It will not have any edges because, of course, remember, it's circular. And it doesn't have a vertex either because, remember, this is circular. For the next one, if you notice here, I have 1, 2, 3, 4, 5, 6 sides. A six-sided shape is going to be a hexagon. So this is a hexagonal pyramid. So in this particular case, my vertices would be all of the letters that I see here. So A, B, C, D, E, F, and G. My edges will be all of the lines that I have. So in this particular case, I would have G to F, G to A, G to B, G to C, G to D, and G to E, as well as all of my sides that make up my base, which would be A to B, B to C, C to D, D to E, E to F, and F to A. Now, because it is a pyramid, I only have one base. That base is made up of those 6 letters. So A, B, C, D, E, F is my base. Now, for the next one, I have 1, 2, 3, 4, 5 sides. A 5-sided figure is called a pentagon. I have 2 bases, so this is a pentagonal prism because I have 2 bases. Now, my vertices are all going to be all of the letters that I have here. So A, B, C, D, E, F, G, H, I, and J. My edges will be all of the lines that we can see. So it would be A to E, E to D, D to C, C to B, B to A. I would also have A to F, E to J, D to I, C to H, and B to G, as well as all of the ones at the bottom here. F to J, J to I to H, H to G, and G to F. Now, my bases, again, would be my top and bottom. So it would be A, B, C, D, E for the top, and F, G, H, I, J for my bottom. And that's all you need to do whenever I ask you to classify the figure as well as name the vertices, edges, and bases. For the next part here, as you can see here, I have one base. That base is a square that's in the middle. Now, it's a square base. I only have one, so because I only have one base and my base is a square, that means this is a square pyramid. Even though these are all triangles, because my base is a square, it is going to be a pyramid. And let me show you what that looks like. So over here, remember again, I have a square base. And as you can see, when I open it up, I have all these little triangles, and that's what it's going to look like, okay? For the next one, I have a whole bunch of little squares. Now, as you guys can remember from the one that I showed you before, all that is showing you is a picture of, let me pull it. A rectangular prism. And the last one, of course, you guys know that one. That one's gonna be our cone. So if you remember from before, and I'll pull it out again, if you have one circular base, and then when you open it up, it looks kind of like a semicircle, that's what it's going to look like. All right, as far as cross sections. Cross sections, remember you want to look at what is going to be parallel to your particular base. So this cross section cuts that circle or the cylinder right in half. Because it is parallel with my bases are circles. So that means this cross section will then be a circle. For this one, this is a cone that it has cut in half. So if you imagine cutting a cone in half, the shape that you will actually get will be a triangle. For the next one, I have a cylinder. For the cylinder, all you're going to do is cut it right down the middle. Now, if I cut a cylinder down the middle, it is parallel to whatever my face will be. And if you remember from my cylinder, when I showed you before, if I cut it right through the middle, the shape that I'm gonna have will be a rectangle. So remember, whenever you're looking at cross sections, you wanna make sure that your cross section is going to be the shape that is parallel to where it cuts it in half. All right, for the next section, all we are going to do is use Euler's formula. Now, Euler's formula says F, which is our face, plus my vertex is equal to my edges plus 2. So for all of these, this is the formula in which I'm going to be using. Now, all you need to do is just put in what they have. Whatever you don't have, you could put as X. So for the first one, I have F plus V is equal to the E I don't know, so I'm gonna put X plus 2. 4 plus 4 I know is 8, so 8 equals X plus 2. I need to move the 2 over to the other side, so 8 minus 2 is going to be 6. So my answer here will be 6. For the next one, I know that I have 20 plus, I don't know my vertices, so I'm gonna put X is equal to 30 plus 2. 30 plus 2 gives me 32, so 20 plus X is equal to 32. Subtract the 20 from both sides, so 32 minus 20 gives me 12. And that's my answer. Next one again, I'm doing 12 plus x is equal to 30 plus 2. Again, we said 30 plus 2 gives us 32, so 12 plus x equals 32. Subtract the 12 from both sides, so 32 minus 12 gives me 20. For the next one, I don't know my faces, so I'm going to put x plus 5 is equal to 8 plus 2. 8 plus 2 gives me 10, so x plus 5 equals 10. I'm going to subtract the 5 from both sides. When I do that, 10 minus 5 gives me 5. And that's my answer. So for today's lesson, for the first 3, all you need to do is classify the figure. In other words, tell me what the name will be. Tell me the vertices, edges, and bases. After that, you need to tell me what net this will be, what the cross section will give you, and then use Euler's formula for the last one. If you have any questions, make sure you come on my live in between the hours of 11:30 to 12:30, and then 2 to 3. Have a good day.